Now let's look at cross products among the coordinate unit vectors. We want to find I cross I cross j, and I cross k. And then j cross I, j cross j, and j cross k. K cross I, k cross j, and k cross k. Now, if we're finding I cross I, we know that the definition of the cross product is that the magnitude will be the magnitude of I times the magnitude of j times the sine of the angle between them. So if we're taking the cross product of a vector with itself, the angle between them will be 0. So the magnitude of that cross product will also be 0 since sine of 0 is 0. So I cross I then will be the 0 vector. J cross j likewise will be the 0 vector. And k cross k will be the 0 vector. Those vectors' magnitudes will be 0. Now all the others, I cross j, recall its magnitude is the magnitude of I times the magnitude of j times sine of the angle between them, which we know is 90 degrees. So the magnitude of any of these two vectors that are crossed will always just be 1 because each of these vectors, I, j, and k, have magnitude 1 and will always have sine of pi over 2 or 90 degrees since they're all perpendicular to each other. So that will also just be 1. So I know all of these vectors have magnitude of 1. It's just a matter of figuring out in which direction they point. So we have the vector I pointing down the x-axis, the vector j is pointing down the y-axis, and the vector k is pointing upward along the positive z-axis. So I cross j, point your fingers down I, curl them toward j, and your thumb will be pointing upward along k. So it will be a vector magnitude 1 pointing up the z-axis, so it will be k. But we also saw that when you reversed the order you were taking the cross product of, you got negative the answer when they were in the other order. So I cross j is negative j cross I, so it has to be negative k. I cross k, point your fingers down the x-axis in the direction of I. Now, if you're pointing your fingers in this direction and curling them this way, your thumb will be pointing outward in the positive j direction. Actually, it's the other direction. It would be negative j. K cross I, that one's a little easier. Point your fingers straight upward, curl them down toward the positive x-axis, and then we would be pointing out the j-axis. So K cross I is j, which is the negative of I cross k. J cross k, that one's easier if we imagine holding your hand so the fingers are pointing this way, curling them so that they're pointing upward toward k, and your thumb would be pointing outward in the I direction. So j cross k is just I, which means then that k cross j is negative I. Okay, now to help you to remember those, you can always use your fingers and curl your hands, but another way to understand those is by drawing this little circle, I, j, k, in counterclockwise order. If you go counterclockwise, I cross j, you get k. K cross I will be j, and j cross k will be I. So going in the counterclockwise direction, you get these, and then just know that if you're going in the reverse order, k cross j would be negative I, and j cross I would be negative k. So going clockwise is the negative, and going counterclockwise, they will be positive. And anytime you're crossing a vector with itself, you always get 0. So now let's see what we can how we can use those. What I want to do is to actually find some way to represent a cross product using components of a vector. I'm going to do that by actually using the component form. I've got a vector u and v. Now notice u and v, if you look back at the definition, u and v were in R3. You need to have vectors in R3 if you're going to be able to look at the cross product, because it's always in that dimension that's perpendicular to the plane containing the vectors you're taking the cross product of. U is u1, u2, u3. V is v1, v2, v3. So u cross v will just be the cross product of u1, u2, u3 crossed with v1, v2, v3. Now let me write these in the IJK form. So it's going to be u1i plus u2j plus u3k crossed v1i plus v2j plus v3k. Now I'm going to apply some of the properties of cross products. Remember when we had a sum cross a vector or cross a sum? This would be equivalent to u1i cross v1i plus u1i cross v2j plus u1i cross v3k. Now that's just taking this first component and crossing each of the vectors in the second on the other side of the cross product. Now plus u2j crossed v1i plus u2j cross v2j plus u2j cross v3k. u3k cross v1i, u3k cross v2j, u3k cross v3k. Now remember, u1, u2, u3 are all scalars. So this is equivalent to u1 v1 times I cross I plus u2 v2 cross times I cross j plus u1 v3 times I cross k plus u2 v1 j cross I plus u2 v2 j cross j plus, I'm up here, u2 v3 times j cross k. I'm down here. u3 v1 k cross I plus u3 v2 k cross j plus u3 v3 k cross k. Now let's use what we applied above. Anytime you have a vector crossed with itself, you get the zero vector. So this is 0, this one is 0, and this one is 0. Now we have I cross j, and we have a j cross I, which we know this is just the negative of I cross j. So I'm going to replace this with negative I cross j. Likewise, we have an I cross k, and I'm going to change the k cross I to negative I cross k. And lastly, we've got j cross k. I'll change k cross j to negative j cross k. So now, grouping our terms with the like, we have I cross j, we have a U2 V2, and we have a minus V2, V1 U2. Oops, this should have been a 1 here. We have the I cross K. We have a U1 V3. And we have a minus V3, V1 U3. So U3 V1. And then lastly, we have the I cross K. That was the I cross K. We have the J cross K. J cross K, we have U2 V3. Should be a J. Minus U3 V2. Now let's change this. I cross J is just K. So we have U1 V2 minus V1 U2. We have I cross K, which is actually negative J. And then J cross K is actually I. Now, if we rearrange those and put the I component first and then the J and then the K, we get this. Now, what we had was U2 V3 minus U3 V2 times I. Then we had minus U1 V3 minus U3 V1 J. And then we have U1 V2 minus V1 U2 K. Now that's not very easy to memorize, but if you rewrote this in determinant form, where you put ijk in the first row, put the components of u, whatever the first vector is you're getting the cross product of, in the second row, and then put the components of v in the third row, and now expand this on the first row using cofactors. So doing a cofactor expansion, you take I, remember, mark the rows and column out containing I, and then take the determinant that's left times the I. And then we're still expanding on the first row. Now we're ready to take J, mark its row and column out. So it'll be J times the determinant formed by taking the 4 entries here. And remember how you alternated signs when you were doing a cofactor expansion. And then plus K, mark out the row and the column containing K, and you'll have this determinant times K. So you took ijk times those determinants that are left when you mark out the row and the column. And remember, evaluating a 2 by 2 determinant, you multiply down the diagonal minus what you get going up the other diagonal. This product minus this product minus this product. And that's exactly what we got doing it the long way using the ijk form of those vectors.